Welcome to section 3.2. Today we're going to integrate powers of trig functions. I have a list here of the identities that we'll need in order to do that. And let's just review some of our Bible formulas because this will come in handy. The integral of tangent kx is 1 over k ln of the absolute value of secant kx plus c. So they're all going to have a 1 over k out front. For secant, it's 1 over k ln, and now it's secant kx plus tangent kx plus c. You should probably pause the video and see if you can just do these on your own. Integral of secant squared, well, that's pretty simple. It's 1 over k and then tangent kx plus c. And then finally, cosecant is very similar to secant, except there's a negative in front, and it's 1 over k ln absolute cosecant kx plus cotangent kx plus c. All right, powers of sine and cosine. So you don't have to memorize this box. Pretty much you're going to want to memorize the idea of it. And the idea is when you have powers of sine and cosine, if you are able to write the integrand as all sines and pull out a single cosine, then you can do a u sub with u equal sine x. And then du would be cos x dx. Or if a power of sine is odd, you might be able to write it as all cosines and then pull off a single sine, and then you would want to let u equal cos x. And then in the sad event that both powers are even, you're going to have to use the half angle identities, which are up here. This version of the half angle, you'll have to do that. And we'll do an example of that. Okay, so let's just jump right in. This first example can be done two ways because both the powers of sine and cosine are odd. So let's just go through the one where I pull off a sine. So I'm going to pull off a single sine, and what's left is sine squared cosine cubed. And then I want to write sine squared in terms of cosines. Well, I know sine squared x plus cosine squared x is 1. So sine squared is 1 minus cosine squared x. And now let's distribute. That's cosine cubed x minus cos to the 5th x. And I can let u be cosine. Du is negative sine x dx. So negative du is sine x dx. So when I go up here to this integral, I can rewrite it in terms of u. I'll pull the minus out, minus, and then there'll be a du over here. That will take care of sine x dx. And what's left is u cubed minus u to the 5th. Let's distribute that minus. That's the integral of u to the 5th minus u cubed du. And now when we integrate, we get 1/6 u to the 6th minus 1/4 u to the 4th plus c. And now back substitute, that's 1/6. U is cosine, so cos to the 6th x minus 1/4 cos to the 4th x plus c. Now, these trig integrals get a little bit long. So I'm okay if you want to integrate from here in your head and back substitute at the same time. So you jump right from this integral with the star by it to your final answer, doing this part in your head. All right, and I'll do that in the next example. And then over here, I've got option 2. You can read through this on your own, but here I decided to pull out a cos x, and then I had to write cosine squared in terms of sines, so that's 1 minus sine squared, dot, 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 and I get a different answer, completely different. It looks completely different, but it's actually equivalent to the answer we got. And the reason it's equivalent is these c's are not the same. This c is not necessarily the same as that c. Okay, here I've got sine to the 4th, cosine to the 5th. So there's no options. I have to pull out a single cosine. So I pull out a single cosine, and I'm left with sine to the 4th, cosine to the 4th x. I want to think of cosine to the 4th as cosine squared squared. So that's this square out here. Okay, well, I can replace cosine squared with 1 minus sine squared. So now I've got sine to the 4th, 1 minus sine squared, squared times cosine. I could multiply all this out now but it would be a big long mess. So instead what I'm going to do is do my u sub right now, then I'll multiply it out. So I'm going to let u equal sine x, and du is cos x dx. So this is the integral of u to the fourth times 1 minus u squared squared du. Okay, now I have to multiply all this out before I can integrate. That's the integral of u to the fourth, and then 1 minus u squared squared is 1 minus 2u squared plus u to the fourth du, and that's the integral. Let's distribute u to the fourth minus 2u to the sixth plus u to the eighth du, and then as I integrate, I'm going to back substitute. So 1/5 u to the fifth, but u is sine x. So sine to the fifth x minus 2 over 7 sine to the 7x plus 1 over 9 sine to the 9x plus c. You can see the answer is a little long. Okay, next one, we have to use half angle because there are no odd powers. So what I did is I used half angle to rewrite sine squared, and I used the half angle to rewrite cosine squared, and I got this integral here. Okay, what did I do in the next step? I pulled out a 1/2 from this guy and a 1/2 from this guy just to get rid of fractions. I didn't have to do that, but I wanted to get rid of the fractions. So I pulled out a 1/2 from the first set of parentheses, a 1/2 from the second, and I put that out front. 1/2 times a 1/2 is a 1/4. Then I did FOIL. So that's 1/4 integral, first inside, outside, last, 1. And we see that the outside and the inside cancel. And so I just got 1 minus cosine squared 2x dx, and that's what you see on the next line. Okay, now we have to do half angle again because we're still stuck with a cosine squared 2x. So don't worry, this is the last time we have to do this. I replace cosine squared 2x with 1/2 plus 1/2 cos 4x. So you have to double the angle, all right? Then combine like terms. 1 minus a 1/2 is a 1/2. And then I distributed the minus, and so I have this integral here. And now I can go ahead and integrate. This is 1/4, 1/2 x minus 1 over 8 sine 4x plus c, which is 1 over 8x minus 1 over 32 sine 4x plus c. Most often, you won't have to integrate quite this much. You'll be integrating things like maybe sine squared of 4x dx or cosine squared of 2x dx, and you'll only have to use half angle once. Just rewrite this. So let's just look at this one. This would be 1/2 minus 1/2 cos 8x dx, and then you'd integrate. Or this one would be integral of 1/2 plus 1/2 cos 4x dx. And then you'd integrate. Okay, powers of secant and tangent, same idea. If you can write the integral in terms of all secants and pull out a secant tangent, then you can let u equal secant x, du would be secant x tangent x dx. Or if you can write the integral all in terms of tangents and pull out a secant squared, then you could let u equal tangent x. So let's see. In this first one, I decided to pull out a secant squared x dx. And what I'm left with is tangent squared x, secant squared x. So I can rewrite secant squared x as 1 plus tangent squared x. Now I'm using the identity that 1 plus tangent squared x is secant squared x. That's a Pythagorean identity. Now I've got all tangents, and I pulled out a secant squared, so I can let u equal tangent, and du is secant squared x dx. So in terms of u, this is the integral of u squared times 1 plus u squared du, which is the integral of u squared plus u to the fourth du, which is 1/3 u cubed. But u is tangent, so tangent cubed x plus 1/5 tangent to the 5th x plus c. Now, what if I had tried the other method? What if I had said, well, I want to pull out a secant tangent? So I would have written this as the integral of tangent x, secant cubed x, secant x, tangent x dx. Get rid of that. Well, would that work? No, because in order to do this, my u would have to be secant. There's no way I can turn an odd power of tangent into secants using the Pythagorean identity. This would have to be tangent squared or tangent to the 4th. So in this case, there was only one method that worked, the method we did. Okay, this one, again, pulling out a secant squared isn't going to help me. I suggest you try that. I need to pull out a secant tangent. So this is the integral of tangent squared, secant squared x, secant x, tangent x, dx. All right, okay, let's rewrite tangent squared as secant squared minus 1 by the Pythagorean identity, and then we're left with secant squared, secant tangent, dx. So I want to let u equal secant x, du will be secant x tangent x dx. So this is the integral of u squared minus 1 times u squared du, which is the integral of u to the 4th minus u squared du, which is 1/5. I'm going to back substitute. U is secant, so secant to the 5th x minus 1/3 secant cubed x plus c. Okay, one more of these. Solve the IVP. Y prime is tangent squared, and the curve passes through 0, 0. So the idea here is to find y. So if y prime is tangent squared, then the way we're going to get y is to integrate. So y, this is a 3-step process. Step 1 is to find y. Y is the integral of y prime, which is tangent squared x dx. Okay, well, that's not a Bible formula, and I don't know a function whose derivative is tangent squared. However, I do know that if I rewrite this as the integral of secant squared x minus 1 dx, this I can integrate because the derivative of tangent is secant squared. So this is just going to be tangent x minus x plus c. Okay, step 2 is to find c. So we're going to use this information, y of 0 equals 0. That's why I labeled this as y. So I'll put a 0 in for y and a 0 in for x. Tangent 0 minus 0 plus c. Tangent of 0 is 0, so c equals 0. And step 3 is to put steps 1 and 2 together. If c is 0, then our final answer is y is tangent x minus x. Okay, one more. Product to sum identities. Don't memorize them, but they're handy when you need them. Product to sum identities are going to work well for integrals like this. So if we look, let me number these. If we look through this list, the most appropriate identity to use would be number 2, because I have sine 3x cos 2x. So I'm going to use 2 with m equal 3 and n equal 2. So this is 1/2, integral 1/2. Then I want sine of m minus n. So 3 minus 2, x, plus sine of m plus n. 3 plus 2, x, close parentheses, dx. Let's clean that up. I'm going to pull the 1/2 out. This is sine x plus sine to the sine of 5x dx. And now we can just integrate. So this will be negative, the integral of sine is negative cosine, so I'll distribute that 1/2, negative 1/2 cos x, and then another minus, and a 1/5 comes out of this, 1/10 cos 5x plus c. And that is the end of this section.